What's up guys, Luke the Welder here, and today we're going to be fixing the corner of this truck bed. The driver got into some sort of accident and completely obliterated this corner. Look at how that weld split down the middle. Now if we move around to the side part, that's called a gusset, and you can see that there's a large crack along the gusset right there. It's broken, and look how far in it was bent. Man, I don't know what they hit, but they hit something pretty good. You can see where it broke away from the weld if you look up top. That's where it should have been. That's insane. Wow, look at the backside. Man, that's crazy. Look at how it just ripped it and bent it outward. Before I can do any hot work, I have to first remove this running light and wire, as well as this tail light, which I can do by removing these 3 screws, and then I can bring it down and get it out of my way. When I start welding, I'm gonna be putting a lot of heat into this area, and I really don't wanna burn any of the wiring, so I'm just gonna get it out of the way and just play it safe. So I grabbed my brand new impact and a bit for removing those screws, and we're going to get set up and get to work, and it should only take us a couple minutes to remove those screws. I couldn't get a good view of removing the screws, so I just didn't record it, but we got it out of the way. Now, although aluminum is a softer metal, it still takes a lot of force to inflict this kind of damage. I mean, we're talking about 1/4 inch thick. Look at how far back it bent it. That's just crazy. But not to worry, they brought it to the right guy, and we're gonna get them wrapped up and taken care of in no time. Good, now we got the wiring out of the way. Now we can move on to one of the most important steps, in my opinion. This step could potentially save us hours of unnecessary labor and frustration. I always make sure that I take a couple minutes and slow down. I evaluate the full scope of the damage, and then I contemplate different ways that I could potentially tackle this repair. I then formulate a plan to be as efficient as possible. My plan is to start off by cutting off the side gusset, and then I'm gonna flatten it. And then I'm gonna move on to the ramp, where I'm gonna cut into the 3 hinges that are holding the ramp onto the back bumper. Then I will cut off and flatten the back bumper, which I will then weld back on along with the side gusset. I will then grind down, sand, and finish any non-structural welds, and then I'll weld the ramp back on, and we should be good to go. I'm gonna start by using my oxyacetylene torch to heat up the aluminum and soften it so that I can use my channel locks and I can start to shape it while I have it still on the truck bed. It just helps hold it in position so that I can pull it out and get it relatively flat before actually laying it down and flattening it by hand. Now I'm going to use a 6-inch cutoff wheel on my angle grinder. I am a trained professional, and I have been using angle grinders for a very long time. I am extremely comfortable with them, and I do not use a guard, and that is my personal choice. But I highly recommend for any of you that you guys use a guard. I am a bit of a risk taker, but I only do things that I am comfortable with. I always recommend that you guys use a guard and follow any and all necessary safety precautions. These tools are very dangerous. All right, we cut the ramp as well, and it came off like butter. Now we have easy access to the rear bumper, and we can see the entirety of the crack. Now we're gonna grind off the old ramp weld so that we have a fresh slate when we go to re-weld it back on. Okay, now I'm moving on to cutting off the rear bumper where it is bent and broken. And some of you might be wondering why I'm not going to just replace the entire piece or just this whole section, and why I'm taking the time to flatten it out. This is not a standard extrusion that I carry here in the shop, and this company needs this truck back ASAP, so they cannot afford to wait for me to order material. So it's just really faster for me to just take my oxyacetylene torch and heat it up again and just flatten it out and just re-weld it. It's really honestly the fastest course of action in this situation. When I know I'm going to have to hit a piece of aluminum extraordinarily hard with a mini sledge, I use a wooden 2x4. This helps soften the blow on the aluminum, which prevents me from causing major dents that I would not be able to buff out later. I am now using a very old vise that will help me straighten up the edges. I don't really have anywhere outside that I can bolt the vise down to, so for now I'm just making it work on the ground. Nice. 1,000 times better than it was. All right, we got the other piece done. Let's move on to the side gusset. All right, now I'm gonna take my angle grinder with a flat disc and I'm gonna go around all the edges so that I can prep them for welding. I gotta clean up all the oxidation on the aluminum, which will make for much cleaner welds. All right, now we're ready to re-weld the rear bumper back on. I'm gonna start by tacking the parts on autogenously, meaning without filler rod. I'm just using the metal that's there and welding it together just enough to hold it in position so that I can go back and add filler rod just after. Right now, with one eye closed, I'm lining up the edge of the part that I just welded with the rest of the rear bumper. Looks good for my house. There are many different forms of welding, but I specialize in aluminum TIG welding, which happens to be the perfect fit for this project. When TIG welding aluminum on a vertical straight up and down weld, you want to start at the bottom and work your way up, holding the torch at an upward 45-degree angle. Now that we got that other side tacked up, we're going to tack up the side gusset. Nice, it's all tacked up. Now let's get to welding. Now you'll notice that I'm using oxyacetylene torch to preheat the weld area. Aluminum is absolutely phenomenal at spreading out heat and dissipating it very quickly, so it requires a much higher amperage in order to be able to weld it. Another factor to take into consideration is the material thickness. The thicker the material is, the more it dissipates heat, which results in requiring a much higher amperage and temperature in order to be able to reach the melting point of the metal. If you compared aluminum to steel or stainless steel, steel and stainless steel tend to retain the heat a lot longer and in a more concentrated area, thus requiring much lower welding amperages. Now some of you might be wondering where my foot pedal is. I do not use a foot pedal. I actually use an on-off thumb switch, which is on the handle of my torch. You see, welding is all about controlling your heat. And the way that I am able to control my heat with my thumb switch is by stopping and starting, very methodically, I might add. You see, once up to temperature, aluminum actually melts very quickly. And when done in the right way, I can actually continue on welds by starting and stopping as much as I'd like. Another thing to consider is that I don't always have a clean straight run where I can just set one temperature and just go. As you can see, I'm filling all kinds of different cracks going in every different direction. So running a clean straight weld at a set temperature doesn't always work. And there is actually a name for this technique. We call it bumping. This technique is primarily used in the marine welding industry with anodized aluminum. Anodized aluminum is typically found on boat towers. Anodizing is a type of finish. They typically take mill-finished aluminum and they dip it in a tank of anodizing which results in a very shiny, mirror-like finish. Anodized aluminum is phenomenal at resisting corrosion from our salty ocean air here in Florida. But in order to weld anodized aluminum, which can be done, it requires this bumping technique, which most people are not familiar with. Before we can weld anodized aluminum, I have to break down the anodizing, and in order to do that, I have to start and stop. If I were to just run a straight weld on anodized aluminum, I would actually blow through the entire part because it would get too hot too quickly. This can also be used on mill finish aluminum. The bumping technique does not compromise the integrity of the welds, even on mill finished aluminum. Now, although I do thoroughly enjoy using the bumping technique, I do also love when I get the chance to run straight welds. I do thoroughly enjoy it, and it is a lot of fun. Okay, now that we got that done, it's time to move on to cleaning up the hinges on the ramp. So that way we can get the ramp back into position and re-weld it back onto the rear bumper. Putting a squeeze clamp on this round hinge helps keep it from spinning as I grind it. All right, we got them all ground down. Looks good. Before we can weld the ramp back on though, I need to grind the welds down on the rear bumper. And I will say that I properly beveled this whole weld, so that way when I ground down the weld, there was still good penetration left. If you do not properly bevel the weld, when you grind it down flush, you will actually have a crack along the entire weld, and it will do absolutely no good when they go to drive down the street. Eventually, the vibration of them driving down the road will cause that crack to get bigger, and this piece could potentially fall off. So making sure to properly bevel each weld joint is crucial. After grinding my welds down, I always finish it off by using a DA sander. DA stands for dual action. The sanding pad on DA sanders not only rotates, but also oscillates at the same time, giving it a nice, clean, feathered finish, which is ready for paint typically. But in this case, we're not painting it. All right, our rear bumper and our side gusset are completely welded and cleaned up, and now we're ready to put the ramp back on. It even lines up with the other side. All right, the top side looks really good. Now we need to put the ramp up in the air, latch it in. Let's get underneath of it and weld the underside. All right, here's one of the welds. Not too shabby. Let's test out the ramp. Good, works great. All right, we're all done. Ramp is back on, everything's welded back on. Nice. Here's what it looked like before we started. It's a big old crack. And here's the finished product. I was able to get this done in one day. It's almost like it never even happened. I think the customer is gonna be super excited about it, and they'll be glad to have their truck back. Thank you guys so much for watching. I hope you guys learned a thing or two, and let me know what your favorite part was in the comments.